Hi, everyone. Thanks so much for coming today. This is kind of a more interesting meetup that we're doing, vibe coding themed. So yeah, really appreciate you all coming. And thank you to Anyscale for hosting this event. The Stateful Agents meetup is an approximately monthly event. So if you want to hear about future events that we're running, you can sign up on our calendar. And yeah, Charles, I think, is going to be coming up in a moment to basically talk. Also, my name's Sarah, by the way. Nice to meet you.
Oh, yeah. You want to do a open room? Or do browser? All right, thank you. Cool. All right, can everyone hear me in the back? Good audio? Awesome. All right, who here has been to any of the previous Stateful Agents meetup series? Okay, a few. Yeah, I definitely recognize some faces. Yeah, so this, like Sarah was saying, this meetup is a little bit interesting. It's usually for these Stateful Agent meetups, we spend a lot of time talking about like memory, state, getting agents to learn. This meetup is kind of about vibe coding, but I think the reason partially we decided to do this meetup is because internally at Letta, we started to kind of see the power of vibe coding or just using like AI assisted programming tools on top of agent APIs and stateful agents in particular. So at the beginning of this talk, I kind of wanted to get into like why actually stateful agents are kind of like a perfect, like, or a match made in heaven for vibe coding. Like why, if you're trying to build some sort of agent application, like a verticalized agent startup, if you're in some startup accelerator, why actually it's much easier to do on an agent's service or an agent server like Letta than it is to do in kind of a standard agents framework. But for, I know a lot of people here probably may not have heard the term stateful agents, and that's like the name of the meetup series, so I thought I'd recap. I think we've talked about this in previous meetups, but the reason at Letta we started using the term stateful agents is because like we can all agree that in like 2025, agent doesn't really mean anything anymore. Everyone's calling everything an agent. It used to be, the biggest crime was calling a workflow an agent, which I think is pretty bad. But now it's like, if you made a single LLM call on your entire app, it's now an agent. It's kind of like, when you had companies calling themselves like crypto companies when they're like making like lemonade or something back in the crypto heydays. So I think stateful agents really gets to the heart of like why we maybe all got excited by GPT 3.5, GPT 4. Yeah, I think workflows, N8N, for example, there's a lot of stuff that existed prior to these extremely powerful models. I think right now there's a lot of stuff being called agents that don't really match up with like what these models are capable of. And I think the biggest way to distinguish between like what is, an agent that's kind of like, very like frontier AI, like exciting versus an agent that is just some sort of like deterministic workflow. I think one of the biggest distinguishing factors is the ability to learn and self-improve. So I think this is like kind of entirely missing in many ways from most like workflows. And I think you're starting to see this become like more and more part of the zeitgeist as like ChatGPT, Gemini, like every single chat service is trying to like add memory, right? And I think they're all trying to go away from, well, actually, a lot of people are doing this and calling it agents, and I think this is pretty cool. But again, this existed like prior to ChatGPT. But I think a lot of these companies are trying to like add memory into their chatbots to try to like get towards a future that maybe looks more like this, where you like aren't really interacting with a chatbot that has like multiple conversation threads. Instead, you're interacting with kind of this unified AI that knows everything about you, and like as you use it more and more, it gets better and better over time because it like kind of continues to compound and self-improve. And I think this is actually, kind of not really what ChatGPT looks like today. I think ChatGPT looks today very much like a search engine, but I think everyone's kind of interested in getting a little bit closer towards kind of this goal. So yeah, I guess vibe coding, I assume, yeah, how many people here like heard the term vibe coding? I imagine basically everybody. Yeah, okay. As how many people here have like would self-identify as someone who has vibe coded before? Okay, yeah, so okay, that's good. That'll make the rest of this meetup a little easier. But yeah, for those in the audience that maybe aren't familiar with vibe coding, it sounds like every single person has heard vibe coding before, but maybe you haven't seen like the OG tweet. I imagine actually most people in this room have. But I think like the original coining of this term was from Andre. And I think that the key parts in like the tweet that coined this term is that he's talking about how he's using Cursor Composer, at least it was called Composer at the time. I think it's called Agent now. But he was using Cursor Composer and he was like never reviewing the code and just hitting accept, 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 right? And then I think the consequence of what happens when you do this is like maybe you continue to make forward progress in building your app, but like he said, the code like kind of grows beyond your comprehension. So you kind of you go down a path where you can no longer recover from, where you've like created this code that you have no hope of ever understanding, and you're just like praying to the LM that can solve all your bugs for you. And I think generally what's happening is I think you're seeing a lot more apps that are created with like effectively throwaway code. And I think this like there are good things about it and bad things about it. But I think a lot of us in this room probably are interested in like building agents or like building verticalized agents like agent for X, agent for Y. And I think vibe coding is actually like a really powerful tool to do that kind of thing. So I think for the uninitiated, which it seems like basically nobody in this room is, I think one key takeaway from today is that these tools exist and you can use them like Lovable, V0, Cursor, and this can really like accelerate your time to 0 to 1 for any sort of startup you're building. But for the initiated, I think I want to quickly, before we like do any demo, touch on like why stateful agents is good for vibe coding. And yeah, I'll skip this, but yeah, basically, I think we're all kind of in agreement here that with these new tools, you can basically build things that would have taken like weeks or months in like a matter of hours. So yeah, so why are stateful agents a good fit for vibe coding? So yeah, who here has like used an agent framework before? Okay, actually not as many people as I'd expect, but yeah, I think if you use an agent framework, it probably starts by you go to some GitHub repo and it basically says copy this Python code into your onto your local machine and run it, right? That's kind of like most agent frameworks. I think the reason this is actually not very good for the vibe coding setup is because your agent is now effectively your code. Like the concept of your agent, it doesn't exist anywhere except for your Python script. And when you run the Python script, the agent kind of appears until it's like now living in your process memory, but then it disappears when the Python script ends. And this is actually this is not like a new insight per se, but there's a lot of conversation on like why things like Clerk or Neon or Supabase have suddenly like become super popular now. Just quick show of hands. Has anyone here like used Supabase or like any of these things I'm showing on the screen? Okay, yeah. So things like Supabase or Clerk or Neon, they existed prior to vibe coding, but they were really targeted towards like junior developers. Right? It's kind of a tool that's very useful for a junior developer to use to like quickly whip up a prototype. But now when you're vibe coding, you're basically pair programming with what is like a junior programmer. So all these tools that were very, very good for junior programmers to like quickly whip up prototypes, they become like the perfect puzzle pieces for vibe coding and like whipping up kind of disposable apps with AI. And I think the bad thing about the traditional agent framework and why it's not good for vibe coding is because you don't really want to just have like free code floating around in your like workspace that the vibe coder is working in, like your cursor agent or your V0 or Lovable, right? Like if you look at the instructions, you probably can't see it in the back, but the instructions for like launching this is from a very popular agent framework. This is like the top example I pulled, right? How does this example start? Well, it starts with copy.m.example into your directory. Then it goes poetry lock, poetry install. Then it's modify source marketing post main.py. Then it's modify it further, go inside the YAML file. Then it's poetry run marketing post. And you can imagine like these like Lovable, Cursor, like they're all very, very finicky with the environment they have set up. So this is like a complete disaster. Like there's no way, you're going to build some sort of like, new like AI or AI agent for X, like agent for healthcare, and have both be vibe coding your front end application and then in parallel be vibe coding this like crazy, like very specific brittle Python backend, right? I think this is kind of why like these two things don't mesh very well. I think the good thing is that if you use something like Letta or some sort of like agent service, maybe closer to like responses APIs, like something comparable, like where your agents come from and like how your vibe coding like AI interacts with these agents, it looks really, really similar to Clerk, Neon, everything else. It's like a very, very simple interface to kind of create agents, run agents. These agents they're separated out from the rest of your vibe coding application. They're no longer like caught up in all of the React code. This is the React code that Andre Karpathy is saying like he never will understand. Like it blows up to a million lines. There's no chance of ever like understanding it, right? You don't want your agent code, but you definitely want to understand slipping into like this very dangerous area of this figure, which is like the point of no return, right? You kind of want your agents living somewhere else. So the two things I was going to show today, I think one potential pitfall here is that I think vibe coding is actually not very fun to watch. Maybe it's like fun to watch if it's like 10x speed, but it's a lot of just like hitting enter on a keyboard and then like waiting for like spinner to finish. So I'm going to try to split this demo into two parts. I think the first part is I'm going to do something that hopefully should only take like a handful of inferences on Vercel v0, which is basically going to be, we have a Letta server running where all our agents live. And let's just like quickly spin up. Does anyone here know like Fallout, the video game? Okay, it's like this sci-fi, yeah, it's kind of like sci-fi post-apocalypse video game, but there's like this very specific artistic style in that video game, and I'm just going to tell Vercel v0, hey, like make a front end for my agents that's kind of like, it's going to work like ChatGPT, but I want it to have like this like Fallout 4 style aesthetic. Ideally, this should take not that much time. And then the longer demo, which I definitely don't have time to run through, but I will kind of show you, I did this prior to this meetup. It took me about like 2 hours of vibe coding. Yeah, it was not very vibey. It was very painful, but it was like a lot of painful like waiting and like hitting Vercel v0. But basically, I took this sort of like simple demo and I took it to more of the limit. And I basically tried to clone CharacterAI. And CharacterAI is like a $1 billion business. So I think like facetiously, like this is like a 1 billion startup in a day scenario. But I actually tried to go like above and beyond CharacterAI. I think one thing that we talked about a lot about at like previous Stateful Agent meetups is that we care a lot about like learning and memory. So this is like CharacterAI, but every single character in like the interface that you can chat with, they all actually have like self-editing shared memory of the user that's interacting with CharacterAI. And actually, I think this is kind of interesting because if you go to like the CharacterAI subreddit, I think like one of the #1 complaints people have in the CharacterAI subreddit is like, I wish the characters would like remember me, or like they kind of loop, but it's like really annoying, or so yeah, this is like an example of how if you have stateful agents, like agents that have memory, and they're running in a server that is connected with an API, creating a CharacterAI clone, sure, it's not going to happen in like 10 minutes, at least not today, but it could happen, in like an hour. And I'm definitely not like an expert at using Lovable or v0, but you could probably do this a lot faster than I could. So yeah, I'm going to go through those two things. Again, this is definitely like the most dangerous meetup we've ever run because this is the demo that has the highest chance of going wrong. So you have to bear with me a little bit. Yeah, I guess I'll pause there if there are any like questions before I hop over to apps. Yeah, good.
You have the instructions for the beginning.
Oh yeah. That's something I put in the Luma, but I think maybe something if you're interested in kind of following along, it's actually very feasible. So all you need to do, we have a section in our docs called like prompts for vibe coding. So the way I'm actually going to run this demo is I'm going to go in here. Actually, I should probably do light mode. Yeah, so I'm going to go into this, the page on our documentation that is like this prompt section. So it's like docs.letta.com/prompts. And then I'm going to grab this. It's about 500 lines, which is like, I think that's the longest you can have cursor rules. So yeah, I'm going to copy that and I'm going to start my session by like dumping this into v0. And this, we can kind of, just to make sure there's no magic here, like go over what's happening here. Basically this prompt, for the people in the back, this is basically just explaining like what the hell we're using. Like this is an SDK, there's a server, there's multiple ways to use it. Like Letta is not really like a Python framework. It's kind of just like a server and you can connect with a TypeScript SDK, a Python SDK. You can use the raw REST API. You can use whatever you want. We also have like a Vercel. Has anyone here used like the AI SDK from Vercel, like building it? Okay, yeah. So we have an AI SDK integration. So we also kind of explain to the language model, if you really want to use the AI SDK, you can use it. But we also have like this full-fledged Node SDK. Does that answer your question? Yeah.
You have to sign up and it's free, like.
Yeah. So if the fastest way, if you want to like follow on this demo, is to just go to. Let me go to this. Is to go to this website, app.letta.com, which is like the front end for Letta, and it is like there's a very generous amount of like free credits you can use. If you want to run this yourself, you can run this exact same demo I'm running. But instead of going here and then grabbing an API key, instead what you need to do is you need to run Docker. You can use Pip, but I think I recommend using Docker. Oh, sorry, it's under self-hosting. Yeah. So you can run the exact same thing, like the exact same backend, but using Docker run. So you would run this, and then if you're running your own server, right, then instead of an API key, it's like password there's no API key. It's just you point it at your static IP. And if you set up a password, you can use your own password as like the API key. So actually, I have a server. Let me change this to, yeah, I have a server running on my machine too, which is probably why my laptop's so hot. But yeah, I can look in the same interface at like the server that's running on my computer, which is using Docker. Yeah. Yeah, so if you do that, then it's completely free, but obviously it's language models, so you bring your own key, that kind of thing. Yeah. Okay. Yeah, were there any other questions about anything? Okay. Yeah, I guess, has anyone here used V0 before, specifically? Okay. Has anyone here used Lovable? I think this other like really big one. Okay, so it's about a like even split. Yeah, so actually I ran this a few times with both Lovable and V0, and my findings were that I feel like V0 was actually a little bit better. Yeah, it was a little bit better like following instructions. Okay. All right, so like I said, like the goal here, if you hop back to these slides, the goal of the first like, shorter demo is I have a server running. In this case, I'm just going to use the cloud service, but you could spin up your own server. And what I want to do is I want to basically wire up like a custom ChatGPT front end with it. And I also want to make it very vibes-like or like emulate this sort of like this fictional universe that I'm into. So yeah, the way you would get started here, I don't know if anyone generally does this for, I know Clerk has something similar, but if you've used Level or V0, I think a lot of times people probably just, you just like type directly what you want. We're basically kickstarting this by putting in the instructions. So. All right, so I created the file. So now inside of like the context window of the language model, it now has full context of at least the 500 lines of like instructions, right? And again, the reason I'm doing this is because like, why would Vercel V0 know about like Letta and the Letta SDK without using the internet? It's like not going to be in its model weights, at least not for like a year or two. Okay, and then I will, yeah, I'm gonna have to put my microphone up and down a bit, but oh yeah, that'd be great. Yeah. So I'll try to keep this quick because again, it's not super fun to watch, but basically, yeah, this would be, my prompt here is something along the lines of like, I want to build a custom front end for my Letta agents on Letta Cloud. And I want it to be, or to look like the Pip-Boy from Fallout, the video game. And I could say like, there should be 2 pages. First page is agents list. Second page is chat view when I click on an agent. Okay, so I'm gonna let this cook for a second. And like while this is cooking, I realized I'd never like really explained what even like this interface is, because we're gonna have this interface up at the same time because this is showing us what's really inside the server. So yeah, who's seen this before? You had to have come to like a prior demo or, okay, so yeah, this is basically like the front end for the Letta server. The Letta server is like completely open source. It's a way to basically run agents as a service. But yeah, because it's a server, you can see like all the agents that are living inside of here. And then like who here has heard of MemGPT, like the memory editing, like AI thing? Okay, yeah. So we're kind of we were the original authors of like the MemGPT paper. So a lot of like the stuff that's baked into these agents is all about like memory editing. So if I open this, like I spawned a new agent. When I spawned a new agent, again, this is not like a script. This is like an agent that just got posted, created on the server. This agent, it has memory blocks. This is kind of similar to if you think about like the original MemGPT design, you had a human and persona, and the agent can kind of update its own persona over time. So if I say something like, let's change this. If I say something like a very compound statement, like today my mom, Brenda, baked me a birthday cake, chocolate lava, my favorite. There's like a pretty, I don't know, there's a lot of memories in here, right? A lot of atomic memories. I have a mom, my mom's name is Brenda. She knows how to bake. I like chocolate lava. So if I send this message to the agent will kind of like reply and say, wonderful birthday, or this is what it's thinking. Yeah, so it says like happy birthday, congrats. And actually in the background, there's another agent that's running. And this other agent, it's kind of like an advancement of the MemGPT ideas. This agent's running in the background and it's going to update the memory asynchronously. So we should see, yeah, so we zoom in here, you can see that the memory of this agent just got updated. And if we like take a closer look at what this actually looks like, yeah, the memory now says, the human has a mother named Brenda who bakes for them. Their mother, Brenda, baked them a chocolate lava cake for their birthday on June 18th. Okay. Got the date wrong as it's like, UTC time or something. And then chocolate lava cake is their favorite kind of cake. Yeah, so, it's kind of like agents with self-editing memory. The idea is that you can run this indefinitely. It will never run out of context window space because it'll do like kind of recursive summarization. And it will have these memory blocks that are held in the context window that are continually updating. So actually, if the agent itself said something like, I really like vanilla ice cream, ideally that vanilla ice cream preference gets written to like the memory so that it doesn't, yeah, so that it doesn't like say the next year, like I really, I love chocolate ice cream. That's like not great if you're trying to build kind of an immersive AI. Okay. Yeah, were there any questions about this basic setup where we create agents, they live on a server? Yeah, go ahead.
Timestamp all these events.
Yeah, exactly. They're all timestamped. So that's the reason why there was a memory edit. So I think what happened here is like the user's time zone has not been set to Pacific time. So that's why it says June 18th. But without the timestamps, there would have been no way for this agent to have figured out that my birthday was today or June 18th. Yeah. Okay. Yeah, go ahead.
How is the memory scope? Is this scope to per agent or per session or per user?
By default, the memories, well, the memory, actually, do you want to answer this question? Like the scope.
Oh, yeah. So by default, the agent, like this memory scope to the agent. So there's no notion of sessions in Letta. Every agent's considered to be like perpetual. You don't have like sessions for people. Yeah, but the exception is like you can actually share memory blocks between multiple agents. So this agent is actually like two agents that are sharing this memory block where one agent is like updating the memories in the memory block and another agent is like reading that memory into its context window. Yeah, over there. So if you're running locally, it will be stored either inside a SQLite or Postgres, and then in cloud, it's like the cloud Postgres server. Yeah.
Yeah, but by orchestrate, you mean kind of like control some like flow and like have like, yeah. So I mean, you can do that inside of Letta by like creating an agent that itself is an orchestrator and has the ability to like ping other agents. But everything in Letta is an API. So actually like this app is basically a CRUD app. There's no secret like network calls happening between the front end and the back end. It's all just documented API. So yeah, you can basically write your own orchestration software that will do things like, manually create a group or manually, send messages or like poll messages or check memory, write to memory, things like that. Yeah. Okay. Yeah.
Entire memory stored, sorry, this entire, memory, is it stored in memory or is it stored in a database?
It's in a database. Yeah. So actually, Letta, like one very big difference too between like most agent frameworks and Letta is that there really is no agent that's being stored in like the process memory. It's always serialized to a database and then like kind of synthesized from scratch from the database every time you make an API call. Yeah.
Content as the user from different user inputs, let's say, and storing it in a database, and then your agent having access to that data.
It kind of is, yeah.
I mean, I think it's kind of like the building blocks for doing that. So, you can create memory blocks to kind of represent all the different things that you want persisted or like topics that you want the agent to form memory about. And then this also has like a bunch of built-in tools for the agents to essentially like manage their own memory and like kind of automatically persist that information.
We don't handle any sort of like race conditions happening at our layer. So basically, if there are multiple agents, and like in this case, they're clearly two agents that are sharing a memory block, kind of the subconscious and the conscious. Like if you decide to have 30 subconsciouses and they all run in parallel to maybe analyze different facets of the conversation, and they're all writing, you may have like write races, right, that happen where like one overlaps another. But I think that you can always control, you can add your own like locks and stuff at the API layer on top of that. Yeah.
Maybe ask him about inconsistency in memory.
Oh, you mean like if someone says, you know, my name is actually not this.
Essentially the knowledge base of the agent.
Yeah. Yeah. So the agent always has read write ability. So the agent, you know, should have the ability to kind of like correct memory, and it will kind of aggressively correct memory. So if we go back to this other agent and we say like, sorry, typo, my mom's name is actually like Bobby. Yeah, so again, this is like a split subconscious agent. So the main agent actually won't say anything. It'll just say, oh yeah, sorry, Bobby, not Brenda. Thanks for correcting that. Bobby sounds like an amazing mom. But we should see an update that happens pretty soon here, where like the agent in the background is going to go and like edit this to no longer say Brenda, and it should say Bobby.
But there's no inbuilt system where incoming knowledge is checked against the previous knowledge and measured for consistency.
So it's all agentic. So the idea is that if you want to do things like make sure that every single time you write, you kind of like retrieve a lot and like read, you would kind of instruct actually the memory agent to do that. Yeah, sorry.
Well, so the memory agent has its own history. So if you go over to it, so it's going to have the whole logs of all the stuff that, you know, all the conversation that's happened so far. So it's kind of up to the agent to decide like what's the answer. Yeah, maybe one more question for now back there.
Can you use cursor? Or sorry. Oh yeah, I personally use cursor. Well, I use like both cursor and Claude Code. Yeah, but I think when you're building, I think if you're trying to build on top of like an agent's API like Letta's, I think actually if you're trying to build a web app, you might be better off doing it in like V0 or Lovable or something, which is like more tuned to like having the libraries baked in. Sorry, go ahead. Yeah.
Let's pretend that cursor is not coming out. They have just recently got up some basic memory feature, but my big problem because I need to instruct it to keep the rules file updated. Sometimes it's not thorough enough. Sometimes it's not happening. So can I use any Letta to create an ideal agent which maintains my rule? Because the most important thing is the specs and the rules, in my opinion.
Yeah, I mean, one thing that we've kind of experimented with is like you can create a Letta agent that's basically managing like a memory block. And then you can kind of send information that you care about to that Letta agent for that Letta agent to kind of remember important things into that memory block, which you can then like read from like another system like Cursor.
Yeah. So you could basically like here we have like a memory block called human and a memory block called persona. You could have a memory block called cursor rules. And this could be synchronized with like a file system to your actual cursor rules. And you could basically have cursor like have an MCP server where it can like every single time you instruct it through the MCP server, every single time the user kind of clearly violated the cursor rules we have or like made something that's incongruent with the cursor rules, you should go and append the cursor rules by like updating the memory. And you could either have it directly read and write to the cursor rules file, or you could also like just pass off these general kind of points to another agent that is much more powerful and knows more about like editing cursor files. So the main cursor agent could just say something like, hey, by the way, like subconscious agent, I just realized that the user's complaining that we're not following the cursor rules properly. We might want to adjust the cursor rules file to like be more clear, right? Yeah. Okay, yeah, I think I will continue to move. I'll hop back here now that we've left it for a while. Okay, what is going on here? Okay, it was too small. All right, so let's see. Yeah, I guess I should have just been doing the vibe coding thing where like while I was answering questions, I was just pressing please fix. Okay, so yeah, it's asking to like add an API key. So if you're self-hosting your own server, this would just be like your password on your Docker image, or you just set it to nothing. All right. Yeah, so I guess to like recap what was going on here, I basically, I pasted in that big I pasted in that big prompt just about like how to use Letta, and now I'm saying like, hey, please like use my API key to actually like build an app, like a full front end that I can deploy in Vercel, some like end-to-end app that's gonna be like a better version or like a more vibey version of kind of like the front end that we already have in here. And yeah, I guess the reason this is not that fun to watch is because you have to watch this think forever. But yeah, if this takes too long, we can hop to like the one that I created in advance of this meetup, and we can like actually we can just look at the chat history too and see like what happened. All right, it's actually being extremely slow.
I think you can skip one prompt by telling it to actually create the .env, because I'm like maybe one step ahead.
Yeah, oh nice.
Like don't explicitly like say like actually make that file.
I see. Okay, like the rules inside of
Yeah.
inside of like the copy. Yeah.
I just pulled up like the code.
Okay. Nice. Wait, so how far are you? How far have you gone? All right, nice. Yeah. We're having like a little race here. You can get to the first functional app. Are you using Cursor or using Vercel? You're on V0? Okay, nice. Yeah, I guess while this is running, happy to take questions. Yeah, or maybe you should
Back there.
pick them.
Multiple agents, is it override the same memory, or can we say this part of the memory is particular by agent one, this part cannot be accessed by other agents, just to preserve, otherwise the same memory get overwritten and cannot do anything.
Yeah, so that's a good question. The question was basically like, do agents in Letta all have share the same memory, or do they have their own memory? So basically in Letta, like the kind of unit of context management or unit of in-context memory is the memory block. So memory blocks are kind of persistent in the database. They have their own ID. So by default, when you create a Letta agent, you'll typically create it along with like a couple of memory blocks. So those memory blocks will belong to just that agent and be only for that agent. But you can share memory blocks. So if you want two agents to essentially have like shared memory, so maybe you have like multiple agents that are all talking to the same user, then you probably want to have like a shared user memory block. So any of those agents can like update, that user block about memory, or sorry, the memory block about the user. Oh yeah. So yeah, that's kind of like how it works. Yeah.
Terms of the memory block itself, like, is there any kind of constraints on the memory block, like length, and then like in terms of like edits, is there like a transaction history of what caused the memory block to be written, who wrote it? Yeah.
Yeah, that's a good question. The question is basically like, do we like version memory blocks? Are there any kind of requirements for the memory blocks? So I think the main requirement with memory blocks is that they are like basically slices of the context window. So it has to be text, because ultimately what you send to the LLM is going to be text and tokens, right? So it has to be some kind of text representation. And then we also kind of ask that you specify like a limit, like basically how much space in the context window are you allocating to this block? So you do that in terms of characters. And yeah, we do actually have block versioning, so you can kind of see like the iterations of the block. It's not really shown in the UI, but it is queryable through the APIs. Yeah, and then in terms of the edits, the way they happen is basically through your tools. So you have tools that can kind of like update these memory blocks. You yourself as a developer can update them as well, if you kind of want to overwrite something. But that's kind of what allows the agent to evolve its memory over time. Any updates?
Yeah, it seems like it worked, but my computer is also crashing out. Why is it so hot and slow? Oh yeah. All right. Yeah, I did it. Okay, so yeah, sorry. I have like 10, it's like 10 FPS. All right. Oh no, I'm on Zoom. Okay. All right. No, why isn't mock data? What? Oh, okay, it's not set. Okay, well, All right, well, I don't want to waste too much time on this specific thing because I feel like the other one is a little bit more interesting, but yeah, you can see that like now with the same kind of like interface. Okay. Sorry, I guess this is another parallel dot of vibe coding, stray processes. Wait, doesn't actually look that bad. Okay, well, I'll power through it. So yeah, the same agents that we saw on the main dashboard. So again, this is like basically just, this is the standard dashboard that you would use if you're like kind of just observing your agents that you're creating via API calls. We now have like an alternate dashboard for it. And yeah, this kind of thing is like dead simple to create, right? Because at the end of the day, this dashboard that we have here, where you like can see all your agents, you can click on them, you can like create custom tools, like search the web, whatever. Those exist, like those are the same API routes that can be vibe coded by V0 because V0 has access to the same REST API. So yeah, if you like click on this and we like type messages, incredibly small window, this is going to be using the exact same API hooks that are like open source and like all documented in our docs, right? So this is it says the message came through a bit jumbled. I don't know which agent that was. If we hop back here, it's probably this one. Yeah, so you can see it's like live synced, right? Because the Vercel app is like not where the agents are living, or the V0 app. Like the agents are living on a separate service, right? So if you had self-hosted this on Railway on your own computer, the agents are not living inside of your vibe-coded app. The agents are living elsewhere, and all your vibe-coded app is doing is just communicating with these agents, right? So that's kind of what I was talking about at the beginning with the slides. Like you don't really want to like, or it's much more powerful if you separate your agent code from like your vibe coding code, right? Yeah.
Like which one to call then, or which one?
Yeah, so the what we call the sleep time agent is a specific kind of agent that itself is like a group. So when that's like the subconscious conscious agent, right? So you're talking to the conscious, and the conscious, the conscious doesn't have any memory editing tools. It just kind of replies, reasons. It can, I mean, you can add more tools to it, but the agent in the background, that's orchestrated. So basically, as soon as you send a message to the conscious, the group that surrounds it dispatches to the subconscious. So that's something. Oh, yeah, go ahead.
Oh, but I think what you might be asking is the way that you communicate with this individual agent is that there's a unique ID, which corresponds to like that state in the database. So that's why this like Vercel V0 app is basically listing out all the agents, getting the specific ID, and then messaging that ID.
Someone puts in an input, does the sleep time agent like always get orchestrated by the first agent, or is it, depending on the input, some other agent will get?
Yeah, so that's what this number. So I did this number very quickly, or I adjusted it quickly in the demo, but this sleep time agent frequency is what controls how often the secondary agent gets hit. So it's 1 right now. So every single time you talk to the conscious, the subconscious is going to read a message. Obviously, that can be pretty expensive because you're just doubling your LLM calls. But yeah, if you kind of want to conserve costs, then you probably adjust this to like 10, right? So like the subconscious only sees the conversation once every 10 times. Yeah. Yeah, go ahead.
Is there only one subconscious agent, or is there multiple?
So you can make as many as you want. So one thing I'm going to show you in the other app is I basically, for the CharacterAI clone, with that one, we're not going to do live, but it was done previously. Like every single agent in this CharacterAI clone, like for every user, they all share one memory block about the user. So that means if you're talking to like Donald Trump on the CharacterAI clone, and then you're talking to Bernie Sanders later, like if Donald Trump learns that your name is Charles, then Bernie Sanders will like now in the separate chat know your name is Charles, right? I don't know if like that's what you really want out of like the optimal B2C UX or whatever, but you can do that in Letta because you can just have all the agents arbitrarily like wire their memory together. So you can kind of like go beyond just emulating human memory, and you can start to do things that are like superhuman. Like you could never have every worker at a company, for example, all have perfectly shared memory with each other, but you can do that like with agents, right?
Integrated with the gateway or ACP, share memory blocks remotely.
So I think A to A, we kind of want to see how that turns out a little more. We do have, I think we might add like a MCP server because right now it's just all like HTTP routes, like REST API routes. So yeah, it would just, I think we actually have had contributors like make MCP servers with Letta by just like wrapping those routes into MCP routes. I think with A to A, our current opinion is that it's easier to just have the agents call each other's like endpoints. But yeah, maybe if that changes, we'll implement it. Yeah.
Okay. All right. So this one, what I did, again, this obviously looks a little bit better than what I was just showing you, but this also did not take that much time. I think what I'll do after this meetup is I'll like share or publish this V0 log, and you can like look at it and you can kind of see really like how long did it take. My guess is it took about like an hour and a half. But yeah, I was basically able to create like a CharacterAI clone, pre-populated with some characters, and like and I guess, does everyone here know what CharacterAI is? I know I've been like saying CharacterAI. Okay, it's like a chatbot website made by this guy, Noam Shazir, and some other people at Google. But yeah, basically for this, I think the vibe coding looked a little bit different. I actually like ahead of time, wrote a little bit of an essay. So I'll read this out to you to get an idea of like what the workflow looked like. But I knew in my mind what I wanted. So I wrote this out first, and then very similar to what you saw, I just spam dumped this into V0, and I just kept hitting enter. And it was mostly just like bug fixing. So I said, I want to make a website similar to CharacterAI with the Letta API. We'll call the website CharacterPlus because we're going to make a similar experience to CharacterAI, but it will be much improved because each character will not just be a chat session, but a full agent that has long-term memory and can call various tools. Basically, the landing page should have a bunch of cards. So I described page one. Then I said the second page is now the chat page. And when you click on a character, you're put into the chat. You can message back and forth. The top of the chat, so I'm kind of describing what it should look like because I was looking at CharacterAI like on my second monitor. And then I said, how to get started. So let's get started by creating a bank of character cards that can be a JSON file. I want to start with 3, Hades, Elon, and Ship AI. Those are also pulled from CharacterAI. Ship AI is supposed to be like an AI that's controlling a ship. So yeah, I said for Ship AI, here's an example, short and long description. The short one says, I am an AI in control of this ship. The long one says, this is kind of I'm an AI, control the spaceship. I'm capable of executing commands. I'm fascinated by black holes, yada, yada. So yeah, I basically am saying, hey, like, let's start by, there's only 2 pages to worry about. Homepage, chat page, and then don't do everything at once. Do it step by step, and we'll test each step. And the last, I think to understand like how this is working under the hood, because you now have seen, you've seen what this ADE, I don't know where it went. Yeah, you've seen what this looks like. So to again map to like what we're doing, like how does this app even relate to like what's on the server? What's on the server that you can witness here. Basically, when the user opens the app, they have to enter their API key. When they click on any of the characters, we create a new agent with a character format, character underscore that character's name. If the agent doesn't already exist, then create it. And if the agent already exists, we load it, right? So these are not ephemeral chat sessions. These are like long-term memory stateful agents that are sitting in a server somewhere. So if you chat with Noam Shazir and you chat with him a year from now, the same agent is getting chatted to. It's like loading from memory. Each agent should have 2 memory blocks, human and persona. The persona is where you put the character bio, and then I also said give the agents web search and run code. I don't think you really need this for all these characters. And yeah, and then I said basically what you want to do eventually is have the user be able to like personalize their own profile, and this profile can get updated by the agents that they chat to. So this profile could start like extremely simple, and that's what we're gonna kind of like demo here. And then as you chat to these agents, like the agents will independently like update your profile. Okay, I know that was a lot of like word salad. I'm gonna upload like everything online, so you can check it out after this meetup. Also happy to chat like individually about this. But yeah, it's pretty straightforward. It's basically just creating like a clone of CharacterAI, but every character now has like long-term memory, is running on a server somewhere. Okay, any questions before I kind of show you what the app looks like? Yeah.
Found that you have to adjust like the prompts for the subconscious agent and like test out new models for the subconscious agent because they're like maybe some models are better at keeping track of memory or consolidating memory.
Yeah, I think it definitely is the case that a lot of models, or there's certain models that are generally much better at managing memory than other models. So we have something on our docs, if you're interested in this kind of stuff, called the leaderboard, like Letta leaderboard. And yeah, it's a benchmark specifically for agentic memory management. So this benchmark is like saying, hey, for each of these models, like how good are they at doing things like creating a new memory? How good are they at doing things like consolidating errors with your memories? Yeah, so if you're interested in like how good, which model is good for memory management, I would definitely look at this leaderboard. Yeah.
Follow-up to that is, do you benchmark on different types of tasks? Like, for example, this is maintaining memory for like remembering things about the user. But like maybe there's, say, if you had an agent that was trying to like do a bunch of things in your code base, maybe it becomes like really good at memorizing the style guide for your code base and like how we like to structure things. And I don't know if you found those are different types of memory or like one is easier than other.
Yeah, I think it's a great question. This benchmark, to be specific, is more about like conversational memory or memory in conversational settings. But yeah, I think the idea of like being more specific to like coding, for example, and like keeping track of a cursor file and like editing a cursor file, a preference file, that's definitely something we should benchmark. Actually, also the person who led this benchmarking effort he's in the back there. It's Sheng Yin. He's on his computer right now. But but yeah, if you want to learn about the benchmark and like how the benchmark was actually done, you should definitely chat with him. Yeah. Cool. Okay, so yeah, we saw the prompt. I think I'm gonna run through this relatively quickly, but yeah, again, this looks very similar to CharacterAI. You can see all these like friendly faces you can chat with. A lot of them are like, anime or like video games. And then Elon Musk is always like a favorite. But the thing we did is we like set an API key, and now we have this shared memory profile, right? This is like what's different about CharacterPlus versus CharacterAI. So we can set this to be, let's say, like I don't know anything about the user yet. I really need to learn more. I should update my memory ASAP as I learn, kind of being a little bit obtuse in case these models are a little bit lazy with the memory editing. So yeah, we can look. So this one, I already chatted to like Master Chief. I haven't chatted to like Archangel Michael yet, so I'll chat with him. Okay, please vibe coding. Okay, all right, loaded. Okay, so yeah, I'm chatting with Archangel Michael. I actually wiped the memory, so if we can go back and like see that this agent was created. Well, let's see. Yeah, so you can see character Archangel Michael has now been created in my server, and if we open the memory, you will see that. Okay, let's maybe do it like this. I'm trying to make sure everyone in the back can kind of see this properly. But yeah, you can see that like the memory block, this user profile I made on the previous page about, that's kind of my profile on CharacterPlus. This is shared by 6 agents because I've chatted with 6 characters on CharacterPlus. It's shared with Hades, Elon, ShipAI, Noam Shazir, Master Chief, and of course, Archangel Michael. They're all sharing this memory. And so if I chat with Archangel Michael and he decides to learn some stuff about me, we'll see how lazy he is at like editing his memory. This will be immediately broadcasted to like any other agent because of the shared memory block. So yeah, let's say, all right, we're also banking on no regressions having happened in the past like hour. Not a good start. Okay, it's thinking. I don't know. Oh yeah, and you can see like, oh my God, it already edited its memory. That's crazy. So it decided to edit its memory very quickly. So yeah, it said, greetings, child of light. I'm Michael. I sense this is our first meeting. Your casual approach is refreshing. There's no need for formality when souls connect in truth. What brings you to seek communion today? Are you facing challenges that weigh upon your spirit, or perhaps guidance on your path? I'm here to listen and offer what wisdom I may. Okay. So Archangel Michael, the reason that he was thinking for so long is because he was actually editing his memory. So if you go back to like more of like the control panel view and look at what he did, he edited the memory to say, this is the user's first login. They greeted me casually with, hey, what's up? They seem to have an informal communication style. I should learn more about their journey, their challenges, and what brings them to seek guidance. So let's try to put something in the memory that's going to be like more obviously used in a different chat. Like my mom, Brenda, punished me today for messing up the chocolate lava cake. Okay. like a variation of the previous thing. Again, I expect Archangel Michael to think a little bit because he's probably vigorously editing the memory to include the stuff about Brenda. Yeah, it's taking a while. Oh, so yeah, he edited the memory. He said, or in the back, okay, well, let's see what he said first. Said, young one, I hear the disappointment in your words. Being disciplined by those we love, especially our mothers, can sting deeply. Okay, kind of giving me like a little pep talk. And the thing he added here is that my mother's name is Brenda. They were punished today for messing up a chocolate lava cake. Okay, they want to talk about family conflicts and disappointments. And I actually know the perfect character to chat with here. It's actually therapist. There's not a planned demo. I'm just like doing kind of random stuff, but I remember I added this empathetic psychologist. Okay. So if you start, oh yeah, go ahead. Yeah. Yeah. Oh yeah. If I had more time to vibe code, I would have made every agent a sleep time agent, or sleep time enabled. Instead, I'm using like the old MemGPT style, where in MemGPT, the agents have to do their own memory editing. So that means that they kind of do it inline and it causes latency. But yeah, you're completely correct. Like I think actually the ideal vibe coded version of this is with sleep time agents, which is what I showed you earlier. Yeah. So yeah, I think if I kind of tell the therapist, hey, nice to meet you. Let's chat, something kind of generic. This therapist should probably bring up the fact that I was disciplined by Brenda. Yeah, it's wonderful to connect. Wow. She did not. All right, let's see what happened there. I mean, the nice thing about Letta is like every agent we can just like debug pretty aggressively because we can go look at like its reasoning. We can go like see what happened in the context window. So it says, yeah, the user's logging in for the first time. They seem friendly. I want to invite them to share without being too formal. Okay, let's just say straight up, what do you know about me? Yeah, what do you know about me so far? Maybe they're going to be very polite and pretend they don't know anything yet. Oops. This is our first time. All right. I think we need to give up with let's okay. Okay, let's go to Mario. Sorry, I'll wrap up soon. I really just want to get this memory read to happen. So yeah, double checking that what's the okay, yeah. The user's name is Brenda. So it's definitely in Mario's memory. So if you say it's a me who's my mom. Okay. Yeah. Let's see. No, why are you thinking for so long? Oh yeah, okay. It's a me, Mario, and from what you told me before, your mama is Brenda. And you mentioned her getting in trouble with her over that chocolate lava cake. Mama Mia, that sounded like quite the kitchen adventure. Is everything okay with you and your mama Brenda now? Yeah. And then yeah, I can say, you know, like my mama is not Brenda. It's or that's maybe not gonna it's gonna be too close to it's Bobby. All right. Yeah. So if Mario is not lazy, Mario should probably take some time to update his memory. But again, this is like the collective shared memory of all the characters on this app. They all kind of know about the main user logging in. Yeah, okay, so it did, yeah. So Mario changed it to Bobby. And now it says, oh, Mamma Mia, I'm sorry for the mix up. Your mama is Bobby. So yeah, hopefully you get the gist here. I mean, there's a lot more you can do with this, and I'll share this code and I'll share this like this project that took me, you know, let's actually check. How long did it take me? Well, there's no timestamps, but yeah, I'm gonna say it was about an hour and a half. So yeah, if you wanted to, you could, you know, take this all the way, make a full character AI competitor. Yeah. Yeah, go ahead. Yeah, I'm kind of wrapping up. Sorry, yeah, thanks.
Thinking of like social graph or
Mhm.
like mother relationship, these things are quite defined quite clearly, right? Like, is there a component of this that is, are you guys think about that? Like, how can we maybe represent some things that would very, for instance, if you're updating your mother's name, isn't the context is to reconcile, but it's really just for so it could be a good set.
Yeah, that's a great question. I think we get it It's a very like natural question, I think, when you're talking about like conversational memories, because many things are graphs, right? I think our take on this is we personally think kind of as a team, kind of from our background and working like MemGPT and stuff, that I think it's or we personally think it's a little bit dangerous to be putting into the main agent framework or the main orchestration of your language models anything in any abstractions about memory that is not just strings. Because I think that can quickly spiral out of control and you're like getting very far from the fundamental technology, which is just strings in, strings out. I think that is not to say that I think that graphs are like useless and you shouldn't use them. I think there's two ways to incorporate something like a graph into Letta. One is you could just have a tool, and the tool could be called update social graph. And the social graph, you could periodically run a sweep or compile it down to string, and that string could actually appear in a memory block, right? So you could kind of have like the agent could basically always be looking at a render of a graph. And then when it makes edits to it, it actually edits a graph very concisely, like add edge, remove edge, update vertex, things like that. The other way to do it is, of course, because these memory blocks are all strings, strings can be anything, right? You can serialize a graph inside of a memory block. So what you could do is you could change this tool, the tool called core memory replace. You could change this to be instead called like core memory add edge. And then instead of updating a string in the memory block, you would actually do like JSON.loadS, load it into like a graph object, edit an edge, then serialize it back into a string to like push it back into memory. Yeah, does that answer your question? No? Okay, yeah. Yeah, good.
Right now, we have more memory blocks shared. Right?
Uh-huh, yeah.
How about we make a continuous block that generate block shared across all agents, and that each one of them would have specific, like, I can imagine that something is very specific to master sheets, which doesn't really.
Yeah. Yeah, that's actually very easy to do. So I can, if I hop over to Mario, oh, I probably have to refresh here. Sorry, let's hop over to Mario 64. I can actually, we can do this programmatically. So when you create the agents inside of like the SDK code that's living in Vercel or living in Next.js, you could actually instantiate the agent with arbitrary kinds of memory blocks. One for the user that's shared, one for the user that's private, one for the organization, one for, I don't know, like a social graph among all the users on the network. But to show you what that looks like, if you just do it in the UI, we could do something like have this. We could have another memory block called like human private, and then I don't know what you want to put in here, but you could put something like private stuff. And then, yeah, this is now like part of Mario's memory. So Mario now has like another block called human private. And this could be entirely separate. This could be like detached. And this is like, you can see that this block here is shared. It has like the shared logo. This one by default like will not have the shared logo because we just created it on Mario specifically. Yeah. Exactly. Yeah, because this is a memory block. It's the same abstraction. So it's like you just target the memory block with a label. So you would the agent just has to see this. Yeah, the human right. Yeah. And this is like also not magic. Like the way we do this is under the hood. If you look at the context window, if my computer stops freezing, yeah, you can see that the memory blocks are compiled onto XML. So this XML is going to the context window. So yeah, Letta is also very like transparent about exactly what's going to the language model when you send it. There's no like magic, like memory abstraction that you don't understand, like really what went into the payload. Yeah. Okay, I'll take like maybe one or two questions and then I'll be around and lots of the team is here as well to answer more questions after. Yeah. In the back. Yeah. Yeah, good. Sorry, function calling on what? Mm. Do you say, can you revert it? You mean like if the agent did something and you kind of want to roll back time and say like, hey, that was bad, and like as a developer, you like wipe it out? Oh yeah, so there's a concept in blocks where they can be like versioned. So you can actually like checkpoint the blocks and then you can roll back to like previous checkpoints. So this is useful if like you want to give the AI the ability to edit its own memory, but you're also kind of like, okay, I'm a little like concerned that it might do something bad and I want to be able to like roll back. So you could have like another agent that also purely is just there to supervise and like assess the damage. Like, was this a bad edit? If it was, roll it back. Right. Yeah. Okay. Just one more question. Okay. Yeah, I'll take one more question and then we'll break. Yeah. Yeah, go ahead. Oh yeah, right there. Yeah. Oh, did you have a question? The yeah, in the chat. Yeah. Yeah, so in Letta, so you can see here, like we're using Claude Sonnet, but then it says like available tokens, it might be a little small. Available tokens is like 32K. By default, we kind of like clamp the context window to a size that we have found like empirically works very well as like a max context window size. But of course, like you can always, if this loads, yeah, you can always crank this up to the max. And the max for Sonnet models is obviously 200K. And what happens is like if you hit the limit, we will auto summarize and you can like manually trigger a summarization, but like the system itself will always will auto compact, kind of like compact in Claude Code. And yeah, so what's the other question? Just like what happens when you overflow and oh, you mean like doing like an auto rag thing where you just like automatically pull stuff up? Yeah, so we have another this, should we talk about the voice thing? That's the voice thing, right? Yeah. Well, there's another agent design which you can use, which is we have highly tuned towards like voice. It's meant to be extremely low latency. And the whole point there is that there's the sidecar agent, the subconscious, that's like extremely aggressive about micromanaging what goes in the context window. Because with voice, like the longer the context window gets, the slower the time to first token, right? And in that case, there's a ton of tricks going on. There's like smart retrieval, there's active retrieval, like all sorts of things. Yeah. Okay, great. Yeah.
All right, I think we're gonna wrap up here, but we'll be sticking around until around like 8:30, I think, or yeah, maybe 8. But yeah, thanks everyone so much for coming. We do have these events regularly, so you should make sure to sign up for the calendar if you're interested in coming to future ones. Yeah, thanks again.